Hello friends, welcome to Shiksharthi. In this video, we'll be discussing clocks. So let's start. So as always, we'll be discussing this topic in few videos. This is not the only video in which we'll be discussing this, so please be attentive of the same. Now, while we'll be discussing clocks, we'll be discussing these things. First, the terminology used in the clocks. Second, we'll be talking about the topic which is essentially used when we talk about clocks, and that topic is time, distance, speed. Third, while we are discussing basics and various concepts, we'll be focusing on two things. One is the angle made between the hands of a clock and the time. When I say the time, we'll be talking about the time also, we'll be talking about the angle, and at the same time, we'll be talking about the relation between the time and the angle made. For example, if I say that an angle of 60 degrees is made between the hour hand and the minutes hand, the hours hand and the minutes hand, then what would be the time in those 12 hours or 24 hours wherein both the hands will be making an angle of 60 degrees? Or maybe between 12 and 1, what is the time when the angles make an angle of 60 degrees? What is the time when the angle is made, 60 degrees angle is made? Right? Okay. The next we'll be talking about, so when we say that we'll be talking about the concepts of time, distance, speed, I hope we all are aware of the fact that velocity is displacement upon time. So we'll be discussing few concepts of velocity and the displacement. So we know that velocity is equal to displacement upon time, or speed is equal to distance upon time. So the very first concept that we are going to discuss here is, we all are aware of the fact that there are three hands in the clock. Generally, it is seen that people talk about only two hands, and those two hands are the minute hand and the hours hand, but we will be talking about all the three hands. So now when we are talking about all the three hands, what are the parameters on which we will be talking about these things? So we will be discussing the displacement to be covered, the velocity of the hands and the time taken. Right? Okay. So now there is a reason why I have written the hours hand first, followed by the minutes hand, and followed by the seconds hand. After we would have discussed few concepts, I hope you yourself will be able to assimilate why this order has been written. Okay. Now, when I draw a clock, there is a physical clock that I have drawn, and I have drawn only two hands. So let us assume here the lengthier hand that I have made here is the minutes hand, and the shorter hand here is the hours hand. And the third hand which has not been drawn here is the seconds hand. Okay. So now if I have to calculate the velocity of either the hours hand or the minutes hand or the seconds hand, in all the three cases, they'll be covering the entire round. Now, one full round means how much? One full round means a displacement of 360 degrees. Right? So that means the displacement of 360 degrees for one round for all the three hands remains the same. Right? So one parameter we have already fixed. Now, talking about the time is already known. So for example, if I am calculating the velocity of the hours hand, I know that in 1 hour or in 12 hours, whatever. Similarly for minutes hand and for seconds hand. So the two parameters are already known. The third parameter which is unknown, which we are going to calculate now, is the velocity, because we know that velocity is equal to displacement upon time. So can I say, in order to cover one full round, that is 360 degrees, the hours hand, how many hours need to be completed by the hours hand? 12 hours. So can I say 360 degrees divided by 12 hours, which is nothing but saying 30 degrees per hour. Now the velocity, this is the velocity of the hours hand, and the unit is degrees per hour. Now I can convert it to degrees per minute also, and I can convert it into degrees per seconds also, which I have done. So when I convert it into degrees per minute, this comes out to be the same thing. This thing gets divided by another 60 minutes. And when I say further converting it into seconds, degrees per seconds, this thing gets divided by 60 into 60 seconds. So you will come to see that the velocity of the hour's hand is 30 degrees per hour, or I can say it as half degree per minute, or I can call it as 1 divided by 120 degrees per second. Similarly, I can calculate the velocity of the minute's hand and the velocity of the minute's hand to start off with the unit as degrees per minute only. Is just like saying 360 degrees and how many minutes? One full round takes 60 minutes for the minute's hand. So you will see that the first velocity that we would calculate is 6 degrees per minute. Thereafter, we can convert it into seconds and hours, which I have done here. So in seconds, it will be 1/10 degrees per second, and then if I am calculating it in hours, how much would this be? This is 360 degrees per hour. So if I have to just compare between these two, the hour's hand and the minute's hand, which one is faster? The minute's hand is faster. Similarly, I would calculate the velocity of the second's hand, and the basic unit of calculation that we'll do initially is we'll calculate it as degrees per second. So when we are doing this, we know that for the second's hand, one full round is just like saying what? 60 seconds. So 360 degrees divided by 60 seconds makes it how much? 6 degrees per second, and thereafter you can convert it into other units as well, which has been done. So now if among the three, if I were to see which hand is the fastest, though we had known it earlier also, but this is with the help of figures now. The facts were already known, but now with the help of figures, we are trying to prove the facts. So we see if we keep the unit as same, and the unit as same means we are taking degrees per hour. So the velocity of the hour's hand is 30 degrees per hour. The velocity of the minute's hand is 360 degrees per hour. And the velocity of the second's hand is 21,600 degrees per hour. So can I calculate the ratio of their velocities? Yes, the ratio of their velocities comes out to be 21,600. I mean, if I were to take it the other way around, 30 is to 360 is to 21,600, which comes out to be 1 is to 12 is to 720. This is the first and the foremost concept that you need to know before you do anything else. Now, second concept which is equally important here is when we talk about clocks, how do we represent the time in the digital format? So we will always say, for example, if it is 3:15, how would you represent? You would first represent the number of hours followed by the number of minutes and then a colon in between, right? So let us assume that this is the time when you are referring to a time on the watch. So by your watch, if the time is H:M, can we understand from here that the number of hours, the number of hours will always be natural numbers. Now we already know. So now we are going to discuss few concepts of, we are going to integrate few concepts of numbers with clocks. So you will see broadly, time, distance and speed and numbers are the basic topics which will be used in clocks and various concepts and questions on clocks. Okay, so can I say the number of hours? There are 12 hours. So the number of hours would start from 1 and end on 12. And then you can always put it as AM or PM. So that makes it 24 hours in a day. Okay. Now the number of minutes would start from 0. For example, if I have to say it is 3 o'clock, I'll say what? 3:00. Right? So let me put a 00 now here. So the number of minutes also are natural numbers and they vary from a 0 to a 60. From a 0 to a 60. Okay. Now, the second and the last concept in this video that we are going to discuss, because after this we will be discussing in the subsequent videos, we will be talking about few more concepts which will be a direct application of these two things. Okay, so can I say in 1 minute the displacement, now dm here is the displacement of the minute's hand, is 6 degrees. And how am I able to say this? Because in 1 minute, can I say velocity is nothing but displacement upon time. So it is just like saying in 1 minute, the displacement of the minute's hand is 6 degrees. And similarly, the displacement of the hour's hand is half a degree. So in m minutes, now why do I say in m minutes? For example, if the time here would have been at 3 o'clock, what angle would have the hour hand made with the minutes hand? So if the time would have been at 3 o'clock, let us assume that this is the 3 o'clock from your side, or let's do it like this. From your side, this is the 3 o'clock. So now this is your minutes hand and this is your hours hand. Okay. Now what is the angle that this minutes hand, this hours hand is making with this minutes hand? So for this, let us take this hours hand back as we have taken it here. And now you are making it travel 3 hours. So traveling 3 hours means what? It is just like saying in 1 hour, the displacement of the hour's hand is 30 degrees. In 1 hour, the displacement of the hour's hand is 30 degrees. So in h hours, the displacement of the hour's hand would be how much? 30 into h is what we have written there. 30 into h degrees. Now if it is at 3 o'clock, this angle would be how much? This angle would be 90 degrees. Now please remember, when you're doing this, you are assuming that the minutes hand is not moving. So naturally, when 3 o'clock is approaching, the minutes hand would have been prior to 12 o'clock. Let us say it's almost going to be 3. So naturally, the minutes hand would be just before 12 and the hours hand will be just before 3. But when we are making it at 3, it's just like we are shifting both. So there is a relative motion also in between. Now in order to take care of the relative motion is what we have done here. Now what is the relative motion here? We are saying that in 1 minute, the displacement of the minutes hand is 6 degrees. So in m minute means this minutes hand was also moving towards 12 at 3 o'clock. Just before 3 o'clock. So in m minutes, the minutes hand moves by 6m degrees, and in the same time, when we are talking about the relative motion, the hour's hand would move by m by 2 degrees. So what is there? What is the difference in the displacement in terms of degrees? Is nothing but 6m minus m by 2, which is 11 by 2m. But at the same time, now this was a relative motion. So once it has already made a 3 o'clock, there will be some angle in between. So now the hour's hand was also moving. So from here, we need to subtract the displacement, the absolute displacement of the hour's hand moving, because that is the relative motion that we were talking about. Right? So now, can I say, so as we have discussed earlier, so in the displacement made by the hour's hand in h hours will be 30h degrees. So what is the angle now made between both the hands? It will be the displacement made here and the relative displacement. So you'll be subtracting this. Once you subtract this, you get the angle made between the two hands. So the angle made between the two hands would be how much? You will say, because we do not know as to which one between them is greater, and the angle cannot be negative. So which is why we will say either it will be 11m by 2 minus 30h degrees, or it will be 30h minus 11 by 2m degrees. So these are the few concepts which we will be taking it in the subsequent videos. So as a homework, whatever we have discussed here, please try and prove all these things before we are able to say, yes, this is okay. Yes, these all things are okay. If you really feel that something important has been discussed today which enhances your knowledge base, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon, select all so that you start receiving updates from us regularly. If you want us to do topic specific videos, please put it in the comment section. Thank you so much. Until next time we meet, goodbye.